All right, so now we've got the warning. This meeting is being recorded. We're talking about the exam before we get started. The exam will be on Monday. It will be, the window for it being open will be from 8 to noon. You'll have an hour and a half to do it. But you have to have everything uploaded by noon so that I can go ahead and grade it. How do we upload the pictures? Emily asks. I'm not entirely sure. I assume through Canvas, you'll be able to have the option to upload a file or files. And in the meantime, I will contact my people to get more detailed instructions on how to do that. And I'll put that in an announcement.
Just so you know, we're doing a lab exam for bio, and when you click into it, there's something that says submit or submit assignment. So I believe within the test, you can put like an assignment portion, and then after someone takes a picture, then they can upload their PDF right in there.
Okay.
So it's called submit assignment.
Okay.
Which picture we have to upload, the homework or the test himself?
Just the test. Yeah, I'll be honest, guys, I have no interest in trying to see who did and who didn't do the homework. You know, you're going to upload 20 pictures of stuff, and what am I going to do? Flip through it? As I've been quoted before, I can think of better ways to kill myself. Upload assignment.
Can you go into more detail about the exam, like exactly how it's going to work and what's going to be, what we're going to draw and that kind of thing?
Well, as far as how it's going to work, right now I've never done this, so I would be speaking out of ignorance, except to say I'm going to make an exam, make a PDF of it. I'm going to upload that as your test, or I'll just write out the questions one by one, in which case you'd have to copy it down and write it out neatly on your page. I don't know if I have the ability to upload a PDF that is sort of downloadable and then printable. And I don't know if everyone has access to a printer. So some people may have to write the exam, hence the extra time to take it. You know, I'd normally give you guys an hour. I'm going to give you an hour and a half. Just because there's so many unknowns about people's technology, what they have access to, and the like. I'm trying to make this as equitable as possible for everyone. Hence the flexible time, the extra time, and somehow we'll work it out. But essentially, either I'll just have the questions written that you'll be able to view in some sort of format online, or I'll have a PDF that you can open up on your computer. And if you have the ability to print it, you can print it and then go. Or if you're just going to rewrite the question and then answer it to go from there. Since I have no idea how that's going to work out, I'm sure I'll get different degrees of ways of answering it. And I wish there was a way of doing it. But since all of our distance ed people are entirely swamped right now because 95% of us have never done an online thing, they're getting tons of questions right and left. Just yesterday, I had to have the guy take control of my computer to show me how to do some of this making of a test online because he's at home. So we had to do all this remote stuff. That's the other reason why I wanted to postpone until Monday for the test, because I'm going to need a few more days to figure out the best way of doing a delivery. As I get more information or get it locked down a little bit better, I think I'll go ahead and send out announcements detailing it a little more so we can have more time for questions regarding it. I know some of you have taken online classes and taken online tests. So if when I send out the announcement, you're like, hey, but what about this? Because my prof does that. That might give me a little more direction to hone in on the best way of doing this. Again, as far as homework, I just don't see a good way of me being able to flip through this stuff without taking even more time. As April says, do the homework and it'll help you. Don't do it and it won't help you. that's really what it comes down to. Normally I use homework as a way to
Lost you.
Forrest?
I think you disconnect.
Hello.
Hello?
Hello?
The teacher got kicked out. Janet is the host.
It's
Whoever that is.
probably his internet.
Oh.
So anyway, we were talking about intermolecular forces.
Okay.
And the
We're
dipoles.
actually going into the nomenclature, which is super difficult.
Is it?
It's like a
Oh
lot
my
of
gosh.
memorizing. There's no real way to
Still being recorded.
hurry. Everybody say something bad. Just kidding, don't.
If a forest drops around and no one's around to hear it, does it make a sound?
Who just said that? That is hysterical. Who just said it? I want to know. I heard Dominique's laugh.
Me.
That was good. I hope that got recorded.
Oh yeah, he's still recording. Oh wow. All
Awesome.
right. PG-13 guys.
I said, if a forest drops and no one's around to hear it, does it make a sound?
So I'm thinking he probably is gonna send a new link.
He may jump back into this one if he has the code.
Yeah, he can just jump back in.
Okay, yeah, he hasn't sent an email.
Are we gonna have to turn in our labs?
Yeah, he already uploaded one of the labs, I see.
Do we just do it on there and submit it?
Said that he'll have a video of him and the other instructor doing the lab, and we will do our pre-lab, use the information that we got off of them doing their lab, and then do the post-lab, and we'll take pictures of it and turn it in.
So Forrest just sent a message saying rebooting.
Oh, okay, yeah, so
That's
wait a
fine.
minute.
We'll send the labs back to Forrest in a PDF.
Yes.
Okay.
So, but you'll take the information from the lab that they did. So the video that they post, you'll take the information that they're getting to do.
Yeah, so you just take that data and put it on and transfer it onto your paper.
Yeah.
Oh, I see. I see. Okay.
Is that experiment 6, which is listed on Canvas?
Yes.
Yeah.
Okay. I don't see it. Okay, so there is no video. There's just a bunch of PDFs right now, correct?
He said he was going to figure it out because I told him that when we first got on this.
Okay. Cool, thanks.
So we're gonna do experiment 6 in our lab manual.
Yes, you will, but you'll use the data from his video.
Okay. And then just take a picture of it and send it to him.
Yes, in a PDF.
Okay. Thank you.
You're welcome.
Does anyone know when the lab is due?
I don't think he said that.
This lab look hard.
Oh, okay.
All right, is everyone there?
Yes.
We're here.
All right.
We're here.
All right. So who's the host now?
We were all hosting. We were talking about the,
Can you not?
Oh,
Okay.
Jeanette Sandoval.
All right. How do we transfer stuff back? I want to host. Are we still
I think
recording?
she should be able to transfer it to you.
Yeah, Jeanette, you need to stop sharing. And then Forrest, you need to share.
Share what?
He needs to share.
oh, share screen.
Share screen.
How do I do that?
So go to your bottom. So somehow you may have hit it accidentally. So if you're on the screen, like hover at the bottom or the top and you'll see like participant share screen. Or it might say, or there
It
might
should be
some-
right next to the chat box.
Yeah, it
I
should.
don't think she's sharing her screen. I think
No.
she needs to hover over Forrest's photo. There's the blue little 3 dots and click on that, and there should be something that comes down that says change host.
Oh, okay.
So it's not me?
No, it's
Okay.
So just so everyone knows, we're trying to figure that out. I tried moving my computer to reposition it, and apparently the button I was touching was my power button, so I shut down. So sorry about that. Also, that means I also need to figure out where OneNote is. Okay, we're still back in nomenclature. All right, am I back in control here?
No, Jeanette is. Oh, there you
You all
go.
see me?
There you go.
yeah,
Okay,
there it
cool.
goes.
All right, so we'll just leave it there for a minute. And then I need to get this chat, well, actually I need to go back and I need to get the chat window up because some people keep insisting on typing. All right. All right, so where were we? No, my chat window didn't stay up. Where the heck? Where the heck? Where the heck?
It should be on the bottom.
And there we go. All right. So I lost that chat bubble, and that's okay. And I just lost, oh my gosh. Stop share, get the chat, get rid of participants, come back here, get the chat. Sorry guys, I'm pretty inept here. All right, chat window's not gonna overlay on my OneNote for some reason. So where was I? Once I figure out more details on how to do the things like how to upload and the like for the test and the best way, I'll send out more detailed information via an announcement. We're not going to do the homework. It's, you know, there's no point. Many of you have seen the experiment 6 online.
Yes.
Okay.
Yeah.
Has anyone tried to do it, and is there a way to upload your lab or the assignment via that?
We were just talking about it. We don't know.
Okay. I guess I'll have somebody try to do it. Josh and I did the labs, made a PowerPoint, ended up with a PDF of it with links to things and stuff like that. I'm assuming that he made a way of making an assignment out of it, but I'll double check with him to see how you guys submit that. I assumed he took care of that, but I should probably double check that. In which case I'll be sending out another announcement with all that sort of stuff in it. Okay. Screen share that, go to OneNote. Hey, and my chat window stayed up this time. Okay, so I guess, do we have any other burning questions now that I completely like foobarred this whole thing? We're still recording, right? Yep. So
When does experiment 6 due?
when's it due? Monday. Yeah, Monday. We'll just give you guys a week to do it, or so. If it takes longer than a week because we have snafus, I'll take it late.
I missed something. What do we have to give on Monday?
Hopefully the lab. Hopefully the lab will be able to be done and submitted. If we run into snafus, we'll fix them as we go.
You sending them through pictures?
So, all right, everyone can see what I'm doing here?
Yes.
Yeah.
Okay, so if you go to the modules on the Chem 110 page, you can see a little further down, there's experiment 6, the online version of it. I do have number 7, but that's not posted yet. So it goes through the introduction, talks about the flame test and the PPTs, and then we've done 3 different unknowns for you guys to tell us what they are. I'll double check if Josh has made this some sort of assignment where you can upload pictures of your lab manual. So the idea here is that you've got 3 or 4 pages. You guys all have the smartphones. You go click, click, click. You upload them to finish your assignment, and you're good to go. I, again, will double check that to make sure and send out confirmation and or more detailed directions as appropriate. And it shouldn't take you that long to look through and sort of see what we did and how we did it. And of course, if you have questions about the lab at all, just shoot me an email or wait for an office hour or something like that. Speaking of office hours, it looks like most people wanted the office hours either right after class or at about the 1 o'clock time. So I'm going to do both. I will, in a normal situation, be done hopefully by about 10:30, maybe 11. I'll hang around, then I'll get lunch with the fam, and then I will come back online at 1 o'clock for office hours. All right. Emily says that sounds good, so I agree. Thank you, Emily. Okay, so the exam. Stuart wanted to know the exam. It is going to consist of me saying, here's a compound, draw it, give me the electron pair geometry, give me the shape, tell me if it's polar or not. It will be, look at these things, tell me the intermolecular forces holding them together. It will be heating curve, drawing and labeling. It will be stuff like that. I can't think of anything else off the top of my head right now. Because I mean,
how many questions is it?
I have no idea because I have to make it up, and it'll be different than any test I've made because I've got to figure out how to present that through an online situation. But I mean, in the past, it's usually been about 25 questions.
So the test will be over your lecture, correct?
Yeah.
Okay, so we can just study off your notes and the homework and we'll be good to go.
Yes, absolutely.
Okay.
And it is the info from chapter 11 and 12, right?
The shapes and polarity and what little intermolecular forces is in that other chapter. I don't know if it's 11 or 13. I think it's 11 in this book.
Okay.
And if anyone's interested, there's an SI session tonight with Zara from 6 to 8. She sent us a note. Just a PSA on that.
I'll be there to follow the class with Zara.
Oh, then I'm definitely going.
Hey. All right, one quick question.
Yeah.
You said that we can print the test out and then take it and send it back?
So what I mean by that is I got to figure out how this works. Is it me just listing out and saying, you know, draw carbonate and tell me the electron pair geometry and its shape and its polarity or whatever? Or am I going to be able to make a PDF 4 or 5 pages long where you could physically print it out, physically write on those pages, and then physically take a picture and digitally upload it.
We just had to do that for statistics, and it worked out fine. She had us print out a PDF. And
well, but now here's the problem with that, Dominique. Does everyone have a printer?
I have a printer. I don't know about everyone. Does everybody have a printer?
I have a printer. I would prefer to do it that way, but if we can't, that's fine.
Right. So I may be able to make up 2 different ways, or even if I have the PDF way and you can't print out, you could always just hand write it out.
Okay.
Right. You know, or at the very least, if you're like, I don't have time for that, you could say number 1 this, and I'll have a copy of it here that I can go like, oh, they're referencing that. Let me tell you, grading this is going to be interesting on my end. So,
well, if it's a PDF, people should be able to type on it and then save the PDF and then send it to you if they're not able to print.
Well, that's if I have the software to make a fillable PDF, and that's if someone has drawing software to draw shapes, right?
Oh, true.
Yeah, so it gets, like I said, for some portions of this, actually for all portions of Chem, it's not as simple as like an English class or somewhere where you're just writing something in or typing it in. We're drawing things, we're showing mathematical works. It is a different animal. So like I said, I'm going to try to find the best way of going about this. I'm going to talk to some other people about the best practices. When I have a better detail about how to do it, I'll send all that out in an announcement, and we're just going to do our best. That's all we can do right now. So you didn't miss anything, Emily? Just in case you're wondering. Okay, so again, you're gonna draw stuff, name it, polarity, compare IMFs, draw heating curves. That's what's gonna be on the test on Monday. What I'm about to start now is for the next test, okay? And that is where we are going to learn how to name things, how to balance equations, how to predict the products of things and why. I will say as I start this that you really, when we start doing nomenclature, for anyone who's taken a Chem course before, nomenclature is usually the bane of people's existences because they think they can just memorize it the night before. And if you do that, it will be bad juju for you. So you want to, as we start this, take this meal in bite by bite and eat slowly but consistently to digest this information. All right, I'm going to go ahead and start writing some notes here. So this section is on nomenclature. Nomenclature. That is a fancy word for how to name. Now, the interesting thing about how to name things is in order to name it, first you have to know what it is. There are different ways of naming different compounds and different things. So the first thing we have to do is to classify the type of compound at which we are looking. So there's a few categories. The first category that we have is the ionic compounds. And the ionic compounds are metals and plus nonmetals. And this is why I can't have the chat. All right, there we go. So it's a metal plus a nonmetal. These ionic compounds are held together by charges. The metals are positively charged, the nonmetals are negatively charged. And examples of this, I'm just going to throw some of them out there. Examples would be good old NaCl or CaF2 or calcium carbonate, CaCO3. That's either marble or chalk, depending on how it's formed. We've got good old NaH, CO3, sodium hydrogen carbonate, AKA bicarbonate, aka baking soda. Maybe Fe2O3, iron 3 oxide, also known as rust, or maybe even something like calcium phosphate, Ca3, parentheses PO4, 2. This is actually, in one form or another, your bones of your body. In each of these, notice that we have a metal on the left, followed by non-metals on the right. Each of these is going to be held together by their charges. You guys might recognize calcium as a +2, fluorine is a -1, so we need 2 of them. Carbonate with a -2, balancing out the calcium there in calcium carbonate. We'll talk about that balancing a little later. We also have molecules. So molecules, specifically binary molecules, these are 2 nonmetals. Now, because it's 2 nonmetals, we are not holding them together by charges, but this is that whole covalent sharing, that octet, overlapping orbitals, so that everyone feels like they have their 8. Examples of this, and keep in mind hydrogen gets to do its own thing, is H2O or H2S or HCl. Those are common ones. We have water, hydrogen sulfide gas, hydrogen chloride, or hydrochloric acid, depending. But just so you know that it doesn't have to be hydrogens, we also have things like sulfur dioxide and sulfur trioxide, SO3, or nitrogen dioxide, or dinitrogen tetroxide, N2O4, or even phosphorus pentachloride. Now, as I put those examples there, I just want to point out, if we look at how I named the ones before, sodium chloride, iron 3 oxide, calcium phosphate, sodium, hydrogen, carbonate, even if I had multiples of those species, I didn't actually tell you how many. When I get down to the molecules, I do. Sulfur dioxide, sulfur trioxide, dinitrogen tetroxide. There's a different way of naming it because it's a different type of compound. The next one is not really a type, but more of a classification, and that is the aqueous.
Hey, Forrest, before you go on, I'm sorry, are you writing those in, what is the order in which you're writing? Like, I know H2O, but is there a reason you would put potassium chloride or 5 as opposed to chloride 5 potassium?
Oh, yes. And that's a good question. Remember, when we were building all these molecules, we said, who goes in the middle? We said, the one that makes the most bonds. Okay, well, over here I've got sulfur and oxygen. They both make 2, so who goes in the middle? Oh, the least electronegative. Okay, well, also when you're building these compounds, you usually put the least electronegative in the front. So if you take a look at that PCl5, phosphorus is the least electronegative. It will go in first. It also happens to have the most bonds. And so just to be very clear, you had no problem with NaCl, right? Do you have a problem with Clena?
Yeah, just because I haven't seen it.
Well, yeah. So the pro tip here sometimes is, if it looks weird, it's probably wrong. Okay. And while Clena is a really good Gaelic band, it's not something that I want to put on my food. Look it up. So the idea here is with ionic compounds, and we'll get to that a little later, it's always metal followed by non-metal. And with the molecules, it is the least electronegative first, followed by the more electronegative after, and or the one that makes the most bonds in the front. As you start working with more of these, again, if it looks weird, you done did it wrong. Okay. Aqueous. Now, this is not really a compound, but more just a classification of things. And as aqueous might imply, what are we looking at?
Water.
Yep. This is, oops. Oh, let's get back to black, just because. This is dissolved in water. And it's given the designation of AQ. So whenever you see this AQ, you know that you're an aqueous. That means you are dissolved in water. So one of the fun things that I like to do, and I just did this with my 121s, some of the 121s the other day, is to remind them of this. Let's say that I have sodium chloride, solid, plus H2O, that is a liquid. What do I make on the other side?
Salt water.
Yeah. So that was Reagan, right?
Yeah, yeah.
Yeah. So how do I write salt water?
Oh,
that's a good question, right? Because
yeah.
Now let me be very clear. Is making salt water a physical or a chemical process?
Physical.
It's a physical. So this really isn't a reaction. But you have to have some way of saying, look, I had solid salt, I put it in water, now it's salty water. So where is the salt? Well, when you put salt into water, it breaks up into its ions. We had that solvent cage, remember from the IMFs, you would say that it broke up into sodium ions and chloride ions. But if you remember, I said they can't be by themselves, and they aren't. They are now aqueous. So this AQ is a way of saying, look, it's not by itself. It's now dissolved in water. And that's a key point that we'll see here in the next section. We have to have the AQ if we are going to say we dissolved it in water. Now, the reason why we have to introduce that is because of our next classification of compounds, and those are the binary acids. Now, as that name may imply, binary means two. This is a hydrogen plus a non-metal. And this is the whole point. It's got to be in water. So it's got to be aqueous. Oops, I wanted that to be red. So it's got to be in water. It's got to be aqueous. Oh man, I'm getting fast at this. I'm gonna be a pro by the end of this. All right. So what might that look like? It might look like HCl AQ or H2S AQ or HF AQ. Now, I do want to point out, let's take a look up there. Here I have HCl and here I have HCl. What's the difference? One's a compound, one's an acid. Okay. If we set the Wayback Machine in this recording, when I said the top one's name, I said it was hydrogen chloride. But when I get it into water, it's now hydrochloric acid. They are two different compounds, and you have to denote that because of the AQ. Now, we have our binary acids, and we also have, finally, our oxy acids. Now, the oxy acids, this is going to be a hydrogen plus something that's called a polyatomic. Now, these are always in water. always in water, so the AQ is often omitted. So because the only way they exist is in water, we just go like, look, it's always in water. I will try to be consistent in putting the AQ, but I'll probably slip up here and again. Examples of these would be something like H3PO4 or HNO3 or H2SO4. Here you notice that I have a hydrogen followed by multiple nonmetals, one of them being oxygen, hence the term oxyacid. And that little part on the end, that PO4, the NO3, the SO4, those are all what we call polyatomics, or more than one atom, and they happen to have a charge. You've already seen one of them. I can just go ahead and put that one up there, H2CO3. We've drawn carbonate a bunch of times. It has a -2 charge, the whole thing. Hence why you need 2 hydrogens to counteract it. Okay, so what we have now here are 5 different ways of classifying these compounds, well, really 4.5. And what we want to do now is to learn how to name them. Oh man, but this is going to take some time, because what we need to do, especially for the ionic compounds, is to learn how to name each of the parts individually. So in order to name this, we have to go and learn each part. So I'm going to start with the ionic compounds. So I'm going to go ahead with purple here. So ionic compounds. Whoa, why are you so big?
Wait, while you're starting, sorry. Did you say the oxyacids are always water and it's a polyatomic nonmetal?
Yeah, so this polyatomic right here.
Right, those 2.
Those are all nonmetals.
Okay.
Right? And H2CO3 is always wet, so we don't always put the AQ. But HCl can either be a gas or it can be an acid. And depending upon how you write it, it'll tell you, am I talking about the gas? Am I talking about something that smells like rotten eggs? Or am I talking about something that's going to eat my boots when I stomp through the oil fields in the middle of winter? Those are 2 different things.
Thank you.
The oxyacids, though, are always in water, so the AQ is just usually left off because it's understood that there's only one way for that to be. Okay, so let's talk about the ionic compounds here. Now, the ionics are, again, the metal plus the nonmetal. And that is the so-called cation, if you remember when we did that, plus the anion. When we were talking about the ionic charges of +1, -1, those are the cations and the anions. So what we need to do is to learn how to name each of the parts, because if you recall how I named things, NaCl was just sodium chloride. The Ca3PO4 was just calcium phosphate. What we're going to do is learn how to name the cation part, the positive, and learn how to name the anion part, the negative, and just smashify their names together. That's how we name ionic compounds. We just take the 2 names and smashy smashy. So first, let's talk about the cations. The cations. Remember, these guys are the positive portion, and this is the metals. There's 2 types of cations we have to talk about. First, we need to talk about the ones that behave. So for cations, if it behaves, And what do I mean by behaves? I mean groups 1 and 2. We just take the metal name and add the word ion. Just use the metal name plus ion. So you have Na becoming Na plus. Well, Na is sodium. And this is just sodium ion. So if it behaves, those groups 1 and 2, where we stood up there and we said, look, what's the charge on this? And you guys shouted out, +1, +2. Those are the ones that behave. And because they behave, I don't have to tell you anything special about it. So again, instead of a group 1, we could take a group 2, let's say calcium. When it becomes an ion, it's always a +2. And because of that, we know that calcium becomes the calcium ion. Now, what if you don't behave? So we have cations. We have the if it behaves. So we have the if it behaves, which is groups 1 and 2, just use the name. What happens if it doesn't behave? If it does not behave. Now, who doesn't behave? Transition metals. Make sure I'm hopefully not going past my, I'm a little nervous about going outside of my lines here. I wish OneNote would tell me what a page looked like. If it does not behave, AKA the transition metals.
It will be endless page with OneNote. It's not gonna tell you when page is over.
Yeah, but when I made your last PDF, I had 3 essentially blank pages because I went like ½ an inch into the quote other page, and I don't like that. So I'm going to try to fix that this time. So if it does not behave, it's the transition metals. Remember when we started predicting the charges, we said group 1 and 2, not a problem. And then I said, just skip everyone in the middle. And that's because, aside from 4 of these guys don't behave. Okay? So if they don't behave, you just have to tell me who they are. So an example would be iron with a 2+ or iron with a 3+ charge. Those are 2 of the charges that iron can do. The way you do this is you take its name, iron, and then you tell us what is its charge in parentheses and using Roman numerals. So you have the iron 2 or the iron 3 ion. So you just use the metal name and you indicate its charge.
Is this only with nonmetals?
It's only with transition metals. Use the metal name and indicate its charge in parentheses. Using Roman numerals. Plus ion. So you see we have the iron 2 and the iron 3 ion. So just so we get through all of the ones you could possibly have, we already have a 2 and a 3. There's a 1, titanium with a 4. Ooh, who could do a 5? That'd be kind of cool. Well, manganese. But I like manganese for 7. Oh no, vanadium. Vanadium will take a 5. Chromium can take a 6. And manganese could take a 7. So just so we know our Roman numerals, in case we didn't learn those back in the day, I don't know if they're still teaching those. We just saw an example of a 2 and a 3 with iron. But since copper can actually take at least 2 different charges there, the +1 and the +2, we would take a look at that plus, and we call this the copper 1 ion. Titanium can do a 2, 3, 4, or 5. No, titanium is a 2 and a 4. So this is titanium 4 ion. Vanadium is a 2, 3, 4, or 5 charge. This one happens to be vanadium 5. And then chromium 6, this is the one that's bad for you, gives you cancer. Chromium 6. For some reason, I have this feeling that Mr. Shaw will know this as hexavalent chromium. In the biz, people call it hexavalent, hexa for 6. And finally, manganese 7 ion. So there we have basically any charge that you could have, it's going to be there. We're not going to go any higher because only one of these can ever go to 8. That happens to be osmium. And if you're familiar with osmium, then great. If not, don't worry about it. But no one will ever go above 8. Can you think of why no one would go above 8?
Then you get into the halogens.
Basically, right? Metals are trying to lose electrons to dump them all off to get back to that noble gas core configuration. The whole point is to get to your outermost shell having 8. So if you're dumping off 9, you're like digging into yourself. You've gone too far. So none of these will get rid of anything more than 8, period. Okay, so yeah.
I'm sorry, real quick. Were you saying?
Hey, Reagan, Reagan.
Yeah, it's me.
Stop
But
saying
that's
sorry.
not my background noise.
Stop saying sorry.
Oh,
Just jump in.
okay. Yeah, I won't. Sorry. It's so terrible. You're right. I should not say that. I shouldn't say that. Were you saying hepta, penta, and septa? Like,
No. So
we don't need to know that.
No.
Okay.
I was saying that there are some people in our class who may have heard or known or had friends who talked about hexavalent chromium. It's an older, archaic way of talking about the chromium 6.
Got it. We don't.
So,
okay. So when we
you're not
say it, I
knowing
would
that,
say.
no, you're not knowing that. It was just a little tidbit. You know, I throw these tidbits out there for people. So it was just to tie into people who may have heard another name for this chromium 6.
Okay, and that's exactly what I would say. Chromium.
Your name is chromium 6. Repeat
Okay.
after me, Reagan. Chromium 6.
Chromium 6 ion.
There you go.
Okay, thank you.
Not a problem. All right, so the cations, the positive ones, okay? If they behave not a problem, just give me their name. I get it. It's a sodium ion. I know it's charged, whatever. You want to tell me it's iron? You better tell me who it is, because who it is will tell me what it makes. And so in all those transition metals, you want to do that. I do want to go ahead and make a very important note. And that is there are 4 exceptions. Note. There are 4 exceptions. And these 4 exceptions are the following. They are aluminum, And I'll just go ahead, actually, let me show that aluminum is becoming. Aluminum will become an aluminum with a 3+. Zinc will turn into a zinc with a 2+. Cadmium, Cd, will turn into Cd 2+. And silver will turn into silver with a plus. Always. So do not tell me it's charge. So it is understood that those four behave. I know they're transition metals. I know they're under the stairs, but they, for whatever reason, that's what they do. If you behave, you don't have to tell me what you're doing. I get it. If you don't behave, you better tell me what you're doing. Okay, so those are the positive portions of ionic compounds. Let's talk about the negative portion. So we have all these cations. Do we behave? Do we not? Note the 4 exceptions. Let's talk about the anion portion of this. So let's talk about the anions. Let me zoom in just a little more. So let's talk about the anions. Right, these are the negatives. These are the non-metals. There are a couple of different types. There's the monoatomic, and then, as I mentioned earlier, the polyatomic. So the monoatomic, as their name might imply, it's only one atom. There are 9 of these. 9 of them, and they all end in, quote, "ide." I'm just going to go ahead and put all 9 of them there for you because there's no point in making this a mystery. They're all the ones you know and love. There's F-, Cl-, Br-, and I-. There's O, 2-, Se, 2-, or sulfur, sorry, sulfur, 2-, and selenium with a 2-. And finally, nitrogen with a 3-, and phosphorus with a 3- charge. In order to name these, all you do is you take the name, but end it in -ide. And you guys probably already guessed this. Fluorine becomes fluoride. Fluorine becomes
Fluoride.
chloride. Bromine becomes
Bromide.
bromide. Ooh, here we go. Iodine.
Iodide.
Iodide. So if you guys remember the Fukushima thing, way back, a few years ago when that plant decided to take a dump, one of the things that people were worried about was the run on people trying to go out and buy iodide to try to chew up the radiation. So many of you might remember that whole potassium iodide shortage people were worried about. And that's just Ki, potassium with iodide becomes potassium iodide. Okay, oxygen becomes
Oxide.
oxide, right? So we have iron oxide. Sulfur becomes
Sulfide.
Sulfide.
sulfide. Oh, here we go. Selenium becomes
Selenide.
selenide. I love that one. Yeah, everyone wants to go seleniumide, right? No, they shorten it up to be selenide. And then finally, I'm going to go ahead and move these guys over because I have a little bit more room.
Nitrogen.
Becomes
Nitrogen.
nitride. And then phosphorus becomes
Phosphide.
phosphide. So there's all 9 of them in one little spot. If I had a cool little periodic table, oh, maybe I do. Hold on. Wait, I can do this. I guess a smart prof would have already had one of these up. When you find one of them, let me know. Let's see if I can get that thing to pop up. Give me that. So, shoot, I don't have the cool whiteboard to scribble over the top, but you guys can see the yellow there.
You know you can add that to your screen directly, right?
No, if I knew that, I wouldn't be saying I couldn't do it.
On the corner of the OneNote, you're gonna see class magnificator. How to say? Let me see on my. Hold on.
Oh, you mean I can import the picture?
Yes, you can import from the net and add directly to your page.
Oh, I don't want to do that because I just want to be able to go back and forth to reference it.
Okay.
But that is a good idea for the future if I have a picture. Thank you for that. So I wish I could hover over so you guys could see. I don't think it's going to let me. No.
Click on your right mouse button, Forrest. So click your right mouse button and see if it says copy image.
Oh, no, I don't want to copy the image. Oh, I see what you're saying.
Yeah, so copy image.
I don't want to do that because then it's going to muck up my notes. It's going to muck up my notes. I'm just going to point out that all the nonmetals there in yellow, you can see that there's 9 of them there, except for the carbon. We're not going to worry about carbon. Carbon doesn't take the charge, right? It shares at all times. We see the group 1 and 2, those transition metals in the pink and the gray. Those are the ones that don't behave, except of course, aluminum, zinc, cadmium, and silver. Now, I do want to point out here too, let me go and see if I can find a better periodic table. Oh no, that'll work. Notice that aluminum is under column 13, zinc and cadmium under 12, and silver is under column 11. That'll help you remember those charges, 3, 2, and 1. Just a little how do you do. It looks like somebody sent me a message, maybe. Let's get back out of there. Let's go back over here. Did I have something on? Okay, I don't see where is it under more for the chat? Chat. Saltwater, for example, the ions in platinum 4 chloride, that would mean platinum has a 4 charge, yeah, positive 4. Yes, we're going to get to that, Nathan.
Thanks.
Yeah, no, we'll get there. First, we gotta figure out the charges of these things, and then I'll show you how to figure it out. Okay, so the monoatomics, they're all there. We all know and love them. Let's talk about the polyatomics. Those monos are going to be pretty easy. We already know their charges. Let's talk about the polyatomics.
Hey, try hitting your ruler at the top. That might give you lines to keep in with if you haven't tried that yet.
Well, it gives me a ruler like that.
It might keep you, if you switch it the other way and put it on the right. If not, no biggie. Oh, no, that actually might help.
Well, there's no, yeah, that's not going to do anything.
Okay, never mind.
Thank you, though. So the polyatomics, as the name implies, it's more than one nonmetal. So this is more than one nonmetal with a charge. And I'm going to go ahead and put the more common ones up so that we can start to recognize the ones that will be used over and over. We're going to have NO3 with a minus charge, SO4 with a 2 minus, PO4 with a 3 minus, CO3 with a 2 minus. I'm going to come over here for the other one. Let's do C2, H3O2 with a minus. We'll do ClO4 with a minus. We'll do HCO3 with a minus. We'll do OH with a minus and CN with a minus. Then I'll put some more up here in a second. I'll tell you the good news and the bad news with polyatomics. I can give you some hints and tips, but at the end of the day, you just need to memorize them. For the polyatomics, most of them will end in the 8 version. There will be some 8 versions here in a second, and I'll show you those. The hints and allegations come from nitrogen here in this polyatomic right here. Nitrogen will become nitrate. Oops, nitrate. Likewise, sulfur in the next one becomes sulfate. Phosphorus becomes phosphate. And of course, carbon becomes carbon 8. So far, so good. And we have clues to their names based on who's in there. Now we get to the ones that might not be as easy. This big C2H3O2, this guy's called acetate. The next one is called perchlorate. And the next one you might be able to actually figure out, HCO3. And want to take a stab at that one? Give you a hint.
Hydrocarbonate.
Very close. Not hydrocarbonate. Hydro means you got it wet. This is going to be hydrogen carbonate.
Yeah.
But good. Hydrogen carbonate. Now the next two might also be sort of familiar to you. OH with a minus charge. Anyone know what that one happens to be?
Hydroxide.
Hydroxide. And for once, I don't have to be scared if someone knows the next one. What's CN minus?
Cyanide.
Who said that?
Massey.
It's a good thing you sit in the back of the room anyway. So anyone who can spout that off and sits in the front row, I get a little nervous because my coffee kept sitting right there. All right, so these are some common ones. Let's do a couple more here just to show you this. We have NH4 with a plus. This is basically one of our only positive ones that we have. And in fact, for this class, it's basically the only one we'll see. You'll notice for the first time, I've actually used the term ion with this one. Technically, all the others should have the term ion after it, the hydroxide ion, the hydrogen carbonate ion. But it's understood that when you say hydrogen carbonate, there's no way for it to be anything but an ion. When you say carbonate, there's no way for it to be anything but an ion. So we often leave the ion off. If you want to put it, that's totally fine. On the ammonium, I really like to always say ion after it. And that's because the ammonium ion comes from ammonia, the compound. And since those names are so similar, I will say ammonia or the ammonium ion so you can hear the enunciation and know which one I'm talking about. The last two I want to point out here, every single one of these is ended in 8 except for hydroxide and cyanide for other reasons. The other ones I want to point out here are SO3 with a 2 minus and NO2 with a minus. You notice those are very similar to our SO4s and our NO3s that we had up there. And I like to put these two in here. These are very common polyatomics that are out there. And these are two of them that end in -ite. So up there we have sulfate with an SO4. Here we have sulfite with an SO3. Likewise, if NO3 is nitrate, then NO2 is nitrite. And for all my wine lovers out there, when they say, warning, this contains sulfites, they're saying it has SO3 2 minuses. And for all my hot dog lovers, when it says warning, if this has nitrites in it, there you go. That's what they're looking at. So what's the good and the bad news of this? That's all I can teach you for doing polyatomics. The rest is practica, practica, practica. You gotta just write them over. You gotta be familiar. You just sort of have to know them. For lack of a better term, because I hate this word, you're gonna have to memorize them. Okay. Any questions so far on, we have our cations, whether they behave or not, 4 exceptions, and the anions, either the monoatomics, which we should have some familiarity with because of just being in the class, or the polyatomics. It looks like I'm getting better at this. I'm seeing a chat pop up. So we basically need to memorize the names. Emily. Not memorize. We know. Yes. I mean, for lack of a better term, you do have to memorize things. But, you know, as I pointed out weeks ago when we were in class together, it's not about memorizing. When you get familiar, when you work with it enough, it's not about memorizing. You know, if I say, what's the symbol for oxygen? Every single one of you in your head just said, oh. Hopefully no one said, oh shit, you know, because that'd be bad. By this time, if you don't know what oxygen is, we got a problem. If I say sodium, you say Na, right? You already know these. Of course, you started out, quote, memorizing them, but now you know them. When you work with them enough, Emily, hopefully it just sort of seeps in. So it's not about memorizing, because you can always forget something you memorized. You won't forget something that you know. Melissa says YouTube has great videos on how to memorize them. Everyone's got their cute little tricks. I can tell you how to learn these if you want to know. If you really want to know, I can tell you the best way to learn them.
Please.
That was me that wrote that. It's Melissa Maribel that's on YouTube, but she does have a lot of good videos, like on all kinds
Oh,
of.
April says, oh, this girl, Melissa Maribel. Oh, I was like, hey, we have a Melissa Maribel in our class? Oh, I thought you were saying Melissa Maribel. There are, oh, I didn't read it. If you really want to know what to do, you go home. Well, we already are home. Never mind. You whip out a piece of paper and you write SO4 2 minus sulfate, SO4 2 minus sulfate, SO4 2 minus sulfate 30 times. Then you skip to the next one and you do it. And even that little exercise right there will just do wonders. And I say this out of experience. The very first time that I was teaching this intro class, I was introducing polyatomics, and I was actually being evaluated by somebody. And I made the mistake of just writing -1 after every single polyatomic, when clearly they're not all -1s. And afterward, the person pulled me aside and said, you don't want to make that mistake, because undoing that mistake is harder than you think. And this person told me, I want you to go home and fill an entire page with each polyatomic. And I did. And that was 20 some odd years ago, and I've never forgotten them since, because of that one exercise that took me 15 minutes of my time. I've never forgotten them. I probably wrote them about 100 times, but I never forgot them. Took me 15 minutes. I know you guys don't like hearing that because it's a boring exercise, but it is useful. Okay.
And just add in here, as being like in a 121 and coming back to review this, you really do use it in every single class going forward. So it is important to like have a handle on them.
Yeah, even, I mean, in biology, they'll just say stuff and they'll assume that you are familiar with the names. And Dr. Moore and Dr. Burns, they'll be just throwing off the stuff, and you're like, oh. They'll be like, oh, the phosphate buffer. And if you don't know that that's the phosphate, you might have some difficulty. You might have to do some extra work. So if you get the work done now, future classes will be a lot better. Okay, whew. This is a long slog, and it just gets longer because now that we have the positives and negatives, we actually have to be able to piece them together before we can just smashy the names, okay? So let's talk about writing the chemical formulas and then how to name them. So before we can name it, we still have to learn how to build it. Let me zoom in just a little bit here. Before we can name it, we have to know how to build it. And that is writing chemical formulas. Writing chemical formulas. Okay, in order for ionic compounds to do this, for ionic compounds, you just balance the charges. For ionic compounds, balance the charge. Now, I'm going to go ahead and tell you right now that I may write some things not perfect, and you'll understand later. So for anyone who's already seen or done this class, you may have a little question about what I'm doing. Just go with it. So if we have a sodium and a chloride ion, so we know that it's an Na+, we know it's a Cl-. Hopefully it doesn't take much of an imagination to see that those charges naturally will balance each other out in a one-to-one fashion. Hence, NaCl. If I have another couple that behave, say calcium with a 2+ and fluoride with a -1, again, balancing the charges, intuition says, well, if calcium is a +2 and fluoride is a -1, then I'll need 2 fluorines to balance out that charge. You guys okay with this? So what happens now? Oh, did I get a more on the chat? Someone says yes. Emily says yes. All right, Emily. What about this? Fe with a 3+ and O with a 2-. Now, in this situation, say?
Fe2O3.
That is correct. Now, there are ways and then there are ways of determining this. I'm going to tell you the better way to go about doing this. This is not a simple way of like doubling one or tripling one or something like that to balance out the charge. Here it's a little more complex because if we just do 2 oxygens, we'll have a -4, which overbalances the +3, doesn't work. So if you have a situation like this, what you would like to do is to look for the least common multiple. So what is the least common multiple of 2 and 3? 6, right? So in fact, since it can't really, man, the online ones are kind of interesting. So what I'm going to do here is do this and say, look for the least common multiple. So the LCM of 2 and 3 is 6. So how many of those iron 3s do I need to make a 6? So we need 2 Fe3 pluses and 3 O2 minuses. Hopefully you guys can see that 2 times 3 is 6, and 3 times 2 is 6.
Do you have to put them in before the FE3?
No, no,
And
no.
the
So I'm
O3?
I'm just showing you, Destiny, I'm just showing you that that's what we're doing for the thought process, okay? I'm going to get rid of the reds here so it doesn't confuse the notes. But what that means is that I would have to come over here and say, I need 2 of the FEs and I need 3 of the oxygens. Remember, the subscripts tell you how many. Does that clear it up a little, Destiny?
Yeah.
Okay. So we'll talk about the least common multiple on a few more examples here as we go along. And especially as we start building more compounds. So let's take a look here and let's see if you guys can make the next cognitive leap here. Calcium with a 2+ and PO4 with a 3-. Ooh, I could call on someone. Oh, except I don't have my thing. Hold on. Let's get to there. Whoever shows up first. Kimberly, you're first. What do you think you would make here?
If you have 3 calcium.
Okay, 3 calciums, Ca3.
And then parentheses, PO4, and then close, and then 2.
There it is. So nice job on that. So when we need more than one of a polyatomic, we must put parentheses around it to group that, okay? So how do we know how to do that? Well, let's not put too fine a point on it, but if we go back, didn't I already tell you? But moreover, we knew that from something else, right? If we recall, when we were drawing out these things, I'm just going to draw it and then erase it. But remember when we did carbonate, the CO3 with the 2-, we did something like this. We put brackets around it and said the whole thing was a 2-. You guys remember that? We did the brackets. We did the brackets to say that is one big chunk. And so how many of those chunks do we need? And that's why we put those parentheses around the PO4 to say we need 2 of that entire polyatomic to do it. So if you need parentheses, by all means use it. If you don't need them, don't use it. And what I mean by that is, let's say you have a K+ and an NO3-. They just come together as K NO3. You don't need parentheses because you don't need more than one. Does that make sense? I love that.
Why wouldn't you put parentheses around the calcium if you need multiple of the calcium?
Ah, good question. Because singular atoms are just that. They're all by themselves. You didn't have a problem with Fe2O3. You didn't have problems with CaF2. And that's because when you have single atoms, it is understood that any subscript after that only applies to that atom. So what would I not put? Let me just put this in parentheses or over here. This is not, let me rest my hand here and do this a little better. This is not going to be Ca3PO42 or something like that. All of that is wrong. You can clearly see in the PO4 too, it looks like I have 42 oxygens, right? That would just be weird. So the parentheses denotes that you someone's mic is back feeding me. The parentheses denotes just 2 of that thing. And if it's just a singular atom, you don't have to worry about it because it's just that atom. Okay. Now, what we want to, go ahead. Oh, I thought I heard someone. Now what we want to do, now that we can sort of build them, is we want to name them. And as I started this whole lecture out, it was all about taking the names and smashing them together. So what I want to do is take the names of each of the ions and smash them together. So naming these. We finally get to the end of it. Naming these, just smash the names together. Just smash, am I muted?
No.
No, okay, good. I wasn't sure if I clicked the wrong button. Just smash the names together. Uh-oh, am I going over? I don't trust myself, so I'm gonna put down here. Just smash the names together. Now, of course, if it behaves, it's easy. If they don't behave, just remember those parentheses. So let's go through here. We have NaCl, okay? The name for the sodium is the sodium ion. Well, we're gonna leave out the sodium part. We're gonna leave out anything that says ion and just say sodium chloride. It behaved. That's CaF2. Calcium behaves. Its name is just calcium. Fluoride behaves. Monatomic. So it's just calcium fluoride. Just smash the names together. What did we have next up there? We had Fe2O3. We had the Fe2O3. Well, we knew that this one was an iron 3, and we know that O is oxide. And we now have to tell you that it is iron 3 oxide. That is distinct from this one, FeO, which is iron 2 oxide. And I'll come to that in just a second. And let's see, finally, just because we had that calcium with the phosphate, the Ca3, parentheses, PO4, 2. Now the calcium, we know its name, it behaves, it's just the calcium. And we know the name for PO4, and that's just calcium phosphate. So with all of these, you just have to smash the names. Now, I guess now is a good time to talk about that whole iron 2 versus iron 3, because how are you supposed to know? Keep in mind that every time we build one of these compounds, one of these metals, especially if it does not behave, is always going to be paired with someone who does behave. Notice that up there, either iron was with the oxygen, iron may not behave, but oxygen does. And even down there with the calcium, even though it behaves, it's also paired with a polyatomic that always has a given charge. So what we're going to be able to do is to sort of back our way out.
So there's a good question.
Oh.
There's a question on the test. It's pretty important.
There's a question on the thingy. Where's the question? Let me go up here.
It says, is it diphosphate?
No, not at all. I don't know why I can't get back to my chat. It's not diphosphate because there's only one way to make calcium phosphate, and it is Ca3PO42. We'll come to that dye stuff here in just a minute. Those dyes and tris and all that come in with the non-metals. I'm going to go ahead and go back up here to the very beginning of this nomenclature and just sort of say it again. If I look at these, I say that this is calcium phosphate. There's only one way. But when I get down here where it's an SO2 or an SO3, I don't just say sulfur oxide, because my first question will be like, which one? SO2 smells like rotten eggs. It sucks, but I can deal with it. SO3 will kill me. You better tell me which one it is. And so because it can be built more than one way, on the molecules, you are going to tell me that di and tri stuff because that matters. But in the ionic compound, once you name it, you have told me the one and only way that that compound comes together. So if I say iron 3 oxide, I know that it is Fe2O3, and there's only one way to write iron 3 oxide. And we'll come to that dis and tris in a second. Those are the easy ones. These are the hard ones because you have to think a little more. You have to think, does it behave? You have to think, okay, how many do I have to balance the charges? So what happens when you get a compound and you're like, oh, I don't get it. How do I name it? So what if I did not already know the charge? What if I did not already know the transition metal charge? Okay, so if I didn't already know the transition metal charge, I can still figure it out. So what if I do something like the following? What if I did TiO2? Well, I ask myself, does titanium behave? Well, if it behaved, that's not a problem. I would just say titanium oxide. There's only one way. But titanium is a transition metal. Oh, I might still have that up. Titanium is right there, number 22. It's a transition metal. It does not behave. And so you got to tell me which one it is. Well, that's easy. It doesn't behave, but guess who does? Oxygenol. Oxygen, what is its charge?
Hang on.
It's a -2, right?
2.
Right? So since oxygen is a -2, since oxygen is a 2-, and there are 2 of them, and there are 2 of them, the right-hand side is a -4 charge. This means titanium is a +4. Now, that is the auditory way of doing it. I can do the mathophile way. So for all my mathophiles,
What? Hi.
what we can do is we can actually make up a quote equation, and we know that titanium plus 2 oxygens equals a 0 charge. I think I saw a chat thing just pop up. Get up, get back here, chat thing. Hey, more chat. My 13-year-old said this is just too easy. Actually, it is, and I want to point out that if you are afraid, don't be afraid, right? It is, once it snaps, it's going to be easy. So when I do this with the math way, I know how oxygen behaves. So that's 2 times -2. That'd be 0. So this is titanium. -4 equals 0. We can do the math, and titanium is equal to a +4. So whenever you are doing this, you're like, oh, that's a transition metal. I don't know what to do with it. Remember, it's always going to be paired with someone who does behave. And all you have to do is look at how many of those that behave are there and back out the charge, in which case you would say TiO2 is titanium or oxide. Some more chats.
Forrest.
Mute.
Oh, that's not my kid.
Forrest. Somebody has their microphone on and it's going over everything you say.
I can hear all the chat in the background and it's starting to annoy me.
All right, let me see if I can figure out who it is.
Boudica.
Uh-oh. Boudica, knock it off. I wonder if I can go to participants and I can figure out who's on. It's gonna take me a minute. Did we already fix it?
We're good. She muted the microphone.
Yeah.
Oh, she's good? Okay. Ulysses has his on, but he's quiet as a church mouse over there, so it's okay. All right. So, what do we have? If we have metal plus non-metal, all we do is smash their names. And again, we don't tell us how many because there's only one way to build it. If you have a problem, you're like, oh, I see it, but I don't know what its charge is. Well, look at the one who does behave. Look at the one who does behave, and it will tell you what the one who doesn't behave is doing. Remember, we talked about these type A and type B compounds. The type A's behave, and the type B's don't, but the type A's will tell on the type B's. For anybody who has a sibling who would tell on them a lot, you understand what I'm talking about. This oxygen is telling on the titanium and saying what it's doing. Okay. Now, I at least want to get to the end of this, and believe it or not, the next part is going to go very quickly. And I'll stay after for some office hours on this if you guys want a little more stuff with nomenclature. But I do want to start to wrap this up because we've been here a long time, and I do apologize. Let's take a look. This was the ionic stuff, right? So this is, oh, get all back up there. Writing the chemical formulas for the ionics and smashing their names. Let's talk about those molecules. We spent a long time talking about ionics because there's a lot of rules regarding around how to name ionic compounds. Once you know them, it's pretty easy, but it takes a while to explain them. This one takes almost no time to explain and everyone gets it immediately. Let's talk about the molecules. So the molecules, I think, who was it that asked the diphosphate thing?
Me.
Who's me?
Destiny.
Destiny. This is where you were getting confused. This is where you may have seen stuff named before, and this is where you're cross-pollinating your nomenclature rules. So molecules, remember, this is going to be two nonmetals. And the thing about these is they can come together in multiple ways. They can come together in multiple ways. So what we need to do is tell us how did they come together, and here's how you do it. To name it, 1, you want to write the first element's name followed by the second element's anion name. Write the first element's name followed by the second element's anion name. That will tell you I'm done naming it. And here's the kicker. What you want to do is use Greek prefixes to tell me how many of each. So 2. Use Greek prefixes tell me how many of each. And we'll go ahead and look at 1 through 10. So the prefix for 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Destiny, your face popped up. Does that mean you're trying to say something? I guess not.
No.
Is there something in the chat? Nope. Maybe we got a chat thing. Thanks for showing the math portion. That helped. Good. I'm glad. You know, some people don't like the math. Some people do. I'm glad that helped. I like the math because if you can think in that sort of way, you can never go wrong. I will tell you this, man, if we were face to face, I had all sorts of like visual cues for you. This will be kind of funny if I start this from day 1 online in summer. I don't know how I'm going to do this, but I may have to. Let's take a look at these prefixes. Most of them you actually know in one form or another. Hey, let's start with the ones we might know. The Greek prefix for 3. Anybody?
Try.
Try. How do you know that?
Tricycle, 3 wheels.
Tricycle, right? 3 wheels. 5.
Penta.
Because of a
Pentagon.
6.
Hexa.
Hexa or a
Hexagon.
hexagon. 8.
Octagon.
Octagon or octopus. Ooh, let's go with 4 because we actually should know this.
Quad.
Tetra.
Oh, tetra.
Ah, tetra.
Oh, tetra.
Right, for tetrahedral. Or as I pointed out in lab, Tetris, right? 4 shapes or 4 blocks each shape. Ooh, let's do number 2.
Die.
That's going to be die. 1.
Mono.
Mono. I bet right now we'd all rather have that than the other. I normally make a mono joke at this point, but I didn't know a good mono joke to make. I'm going to put a little star here. We'll talk about that in a second. Let's do the last ones here. 10 would be the next one we might know.
Deca.
Deca. And deca for?
Decathlon.
Decade.
Oh, decathlon, that's right. Or decade, right? 10 years in a decade, 10 events in a decathlon. The next one here, 7 is hepta. And 9 is nona, which is actually one of the roots for the Latin to finally give us things like nueva for 9.
That or Italian for grandmother.
Wow, I did not know that. Mono is essentially not used. It's not used except with carbon monoxide, nitrogen monoxide, and stuff like monohydrogen phosphate.
Mic off.
I love how you guys are like, and it's just going to police that. Carbon monoxide, nitrogen monoxide, and monohydrogen phosphate.
It's hard to hear you when it's on because we hear their background noise.
Yeah, we'll get the hang of it. Got a little chat here. Bad mic. My mic turned on without me knowing it. Yeah, I mean, we're all going to get used to our computers here fast. So mono is not used except with a few certain cases there. So in general, we're going to leave it off unless it's absolutely needed. And these are 3 that you might have show up in your careers. So, well, clearly carbon monoxide. So let's just go ahead and do some examples. It'll be painfully obvious, I'm sure, pretty fast. that if we do something like NO2 or N2O4 or SO2 or SO3, we might as well do HCl, PCl5, and SF6. That's a 2, 3, 4, 5, and 6. And actually, let's do H2S. I want to put that one up there. So let's take a look at these 6 compounds that I have. In the first one is nitrogen and oxygen. So hopefully you guys can see that this would be nitrogen, and we have oxide, but 2 of them, we'd say dioxide. Now that is fundamentally different from the one below it. Nitrogen dioxide, as you see it, is actually a poisonous gas. This N2O4 is rather inert, and this is now dinitrogen tetroxide. Now, you can say tetroxide or you can say tetraoxide. Both are acceptable. So if you happen to come from a language where getting all those vowels enunciated is part of your language, by all means, I love to hear the tetraoxide. But if you're not, you can just like hillbilly it and just go tetroxide. Okay, so SO2. What do you think?
Sulfur dioxide.
Sulfur dioxide. SO3.
Sulfur trioxide.
There you go, sulfur trioxide. This one might be interesting. HCl.
Hydrogen chloride?
Good.
Yes. Hydrogen chloride. Hopefully I didn't go out of bounds.
Mm-hmm. Then phosphorus.
Yeah. What do you think? Get out of there.
Chloride. Phosphorus pentachloride.
Yes, phosphorus pentachloride.
Oh my God.
Phosphorus pentachloride. And then the next one.
Sulfur fluoride?
How many?
Hexa.
Hexa. Oh, okay.
Yeah. And that's because, and I'm just going to go ahead and point out, you can have SF6, you can also have SF4 and SF2. And that's why you have to tell me how many. So the other one would be sulfur tetrafluoride, the other would be sulfur difluoride. Now this one, by the way, I just want to point out, this is going to be interesting because this is not dihydrogen, but just hydrogen sulfide. And that's because, unfortunately for this one, there's only one way to do hydrogen sulfide. You have to have the two H's. So for all of the HCl, HBRs, all that, they're all monoatomics, that's great. But for H2S and H2SE, since there's only one way to do it, they just name it as hydrogen sulfide and hydrogen selenide.
Is that because they balance out?
Yes, because they will balance out. Now, of course, you should be able to go backward from these. I don't think I have to do examples of that right now, but clearly if you have the name, it'll tell you how to build it. If you see a dinitrogen tetraoxide, that's 2 N's and 4 O's. We might start next Wednesday, I guess it is, with a quick recap, but I'm not going to do it now. I want to get to the last couple here. And that is the binary acid and the oxyacids. So the binary acids. This is hydrogen plus a nonmetal, and this is the kicker, in water, right? So that's going to be our aqueous. There are 6 of them. 6 of them. And they will all be hydro something ic. And you can say acid if you want. What you're going to do there is put the non-metal name. The non-metal name is going to go right there. The hydro means it got wet. The hydro is not referring to the hydrogen, it's referring to the fact that it got wet. So the 6 that we have here are going to be HF, AQ, HCl, AQ, HBr, AQ, HI, AQ, H2S, AQ, and H2SE, AQ. Sorry, my AQs are getting a little weird there. So HF, it is wet. We call this hydrochloric acid. I'm not going to worry about the acid part. Once you say hydrofluoric, the acid is implied. If you put it there, you're doing the most, as the kids say these days. Wait, do you guys still say that? Oh, awkward. Prof got awkward with knowing some lingo.
No.
No, everyone's just blasting me in check. Yes, kind of. Sure. Okay, I'll take that. All right. So HCl is hydrochloric. Oh, I can write better than that.
Hydrochloric.
Hydrochloric.
Iodic.
Yeah, so the HI will get there. So this is hydrobromic. This one is actually said hydroiodic acid. And this one is hydrosulfuric. And this is hydrosplenic. So there's the 6. If you want the 7th one, come to Chem 121 where we find out that water is an acid. It'll blow your mind. There's 6 of them, that's it. And you recognize a couple of them already. Now the trick is, I just want to point out, just a little bit, all by itself, hydrogen chloride. In water, hydrochloric acid. Okay, though that is very important. Very important distinction. And again, we had hydrogen sulfide gas, smells like rotten egg, hydrosulfuric acid, bad juju. All right, finally, let's get to the oxy acids. Almost done today, guys. Oxy acids. As the name implies, we're going to have some oxygen in there. So this is hydrogen plus polyatomic. I'm going to give you some common ones. Common ones to know. There are some others in your book, but you'll notice that I use the lion's share of these right here. The common ones would be HNO3. It would be H2SO4, H3PO4, H2CO3, HC2H3O2, HClO4, Man, I think that's just about it. These are the common ones. Now, there's really no good way of telling you guys how to do this except for, and I hate to say this, I believe it was Emily, memorize. However, if you know your polyatomics, you will know a little bit about how to name it. Specifically, you have that NO3 there in the HNO3. If you know that that is nitrate, then this becomes nitric acid. So this now becomes nitric acid. I'm going to leave off the acid part because I just don't want to scribble everything there. If you recognize this SO4 as sulfate, then sulfate becomes sulfuric acid. If you recognize PO4 as phosphate, this becomes phosphoric acid. Carbonate becomes carbonic acid. Acetate becomes acetic acid or vinegar. And finally, if you have that perchlorate, this is perchloric. Now, just to show you slightly differently, I'm going to put over here, you could have something like H2SO3 or HNO2. You'll notice that that now is one oxygen less than their previous polyatomics. SO4 was sulfate. SO3 is sulfite. And so sulfuric becomes sulfurous. And nitrite becomes nitrous acid. A neat little way, I stole this from a book. Ick, I ate a poison us bite. And what this really means is that ick acids come from 8 ions. The us acids come from, oh, don't be lazy. Acids come from the ite ions. So if you recognize your polyatomic, you'll be able to recognize the oxy acids when we get there. Oh, great. Now you know how to name everything. Okay.
Can you make that bigger so we can, I didn't finish writing. Please.
Oh, not a problem.
Oh, H2SO3.
Yeah, that's sulfurous. You guys will see that again in the experiment 7 that will go live on Monday, complete with videos of Dr. Hansen and myself.
Bye.
So I know this was long. Hopefully being able to go back over it. And of course, next Wednesday when we come back to lecture, maybe we'll start with a little bit. I'll be around after this lecture for some office hours. I'm going to go ahead and stop recording in just a second. Remember, once I have clearer directions for your exam on Monday, I will send out an announcement with those detailed instructions. Any burning questions before I sign off here? We got someone in chat saying, you're going to make me put my glasses on, aren't you? So there's no lecture on Monday, just the exam. Correct.
Can you make the page appear again, share your screen, but
Yeah,
not
can you put that
recording,
back
please?
up on the
Oh,
table?
oh, so sorry. I was just trying to see the questions. There we go. There we go. Okay, so I guess I'll just stall until you guys tell me it's okay because I was going to stop the recording, but
Yeah, you can stop the recording, but keep
Oh, I
sharing your
can.
screen.
Yeah,
I
yeah,
can-
keep sharing.
Am I sharing a screen?
No.
No.
Oh, all right, hold on. Let me just go ahead and stop recording then. Where is more? Shoot. I can't, there, that's stop sharing. Where's stop recording? Get back here.
I think because
Alright.
you weren't the host, you can't stop the recording.
All right. I hope I can, I hope I
Is
still get it.
the recording person. She's the one that's recording.
Who's recording?
I'll go ahead and stop it. Just give me 1 second.